What's up, guys? In this video, we'll dive into the world of container orchestration with Kubernetes, exploring how it works, why we would use it, and then demonstrate a hands-on example using MiniKube with NestJS so we can develop with Kubernetes locally. What is Kubernetes? Kubernetes, or K8s, is an open source container orchestration platform that automates the deployment, scaling, and management of containerized applications. Kubernetes provides a portable and consistent environment for deploying applications across different infrastructure environments, enabling organizations to avoid vendor lock-in and maintain flexibility in their choice of cloud providers or on-premises infrastructure. Let's just take a quick look at some of the problems with manual deployments of containers. So containers, they might crash and they might need to be replaced. We might need more or less containers depending on traffic spikes, and incoming traffic should be equally distributed to these multiple instances of a container. So why K8s? So Kubernetes, we can create configuration files to specify our deployment requirements. So things like the desired number of containers, all of these sorts of things. We can then give this YAML config to any cloud provider, and it can also run locally with MiniKube, as we'll soon see. This provides a standardized config independent of third-party providers, but they can be used with a cloud provider, and they'll create resources and adhere to your deployment specifications. And just to note, Docker Compose, it's a great tool for local development, but it creates all of your containers on the same machine. Whereas Kubernetes, it's like Docker Compose, but it works across multiple machines, which is what we typically would want when deploying containerized services such as microservices in production. We are going to start off by looking at this cluster architecture diagram so we can quickly familiarize ourselves with the concepts needed to make use of Kubernetes. So the first thing you will note here is we have these things called nodes, and these are just machines. So these could be things like EC2 instances or other virtual machines. And you'll notice that each one of these nodes, they hold pods. They can contain one or more pods. Typically, you'll just have one representing one microservice per node. But it's possible that you can have multiple pods as shown in this diagram here. And these nodes, node 1 and node 2, they're known as worker nodes. And these containers, well, these nodes, these machines, they run the containers, so our microservices. It also has this proxy, kube proxy, and this kubelet contained within it. So kube proxy, firstly, a container, we need to have some sort of communication outside so we can connect from the internet to our container. And kube proxy, that allows us to have that inbound and outbound requests. Whereas kubelet, that's a service on the worker node and allows for communication between these worker nodes and this control plane, or there's a thing called a master node, such that this master node, it's able to control all of these pods on the worker nodes. So this control plane, it interacts with the worker nodes to control them, and through this Kube API server, it's able to send instructions to the cloud provider as well, and that then the cloud provider can provision resources. It also has this scheduler here, this control manager here. So the scheduler that selects, you have a whole bunch of worker nodes, and the scheduler helps you select the worker nodes and put new pods in them. And it's sort of related to the Kube control manager, which actually goes ahead and it watches the so the Kube control manager watches and controls the worker nodes overall. and it corrects the number of pods, and they work closely together. And then this Kube API server, this is the master node that contains the API server, which provides a way for the kubelets to communicate. And then the cloud control manager, that's sort of a layer that sits on top of all of that. And that's specific for the cloud provider. So when we're making these when we're making this K8s Kubernetes configuration files and we're setting it up, it's cloud agnostic, but we will deploy it to the cloud. So the cloud specific stuff here will allow, say, AWS to provision those particular resources like the EC2 instances and all of that sort of stuff. So that's, in a nutshell, the cluster architecture and the main concepts that we need to know. And just to note, you'll still need to actually create things like a load balancer and file systems on AWS and create your node instances. Like, you still need to write the code and create your NestJS API, for example, and hook it up to different AWS services and all that sort of stuff. However, what Kubernetes will do is it will manage your deployed application. So it'll make sure that it's running. If it crashes, it'll reset it. It'll scale the number of containers as needed and all of those sorts of things. And it'll do that across different EC2 instances or different virtual machines. And with that, you can see that it's a quite powerful orchestration management tool for containerized applications such as microservices. We need two things to be able to create clusters and interact with them locally. So we're going to need kubectl, and we're also going to need MiniKube. On the Kubernetes website, you can see how we can install kubectl. And kubectl is just a tool for setting instructions to the cluster. This whole thing is known as a cluster, hence cluster architecture. So we've got the worker nodes and the master node and all of the other things in the control plane and everything, your whole application that makes up the entire cluster. So what kubectl does is it allows a way to send instructions to the cluster. So to create, update, delete a new deployment, for example, and then that sends instructions to the master node. So we want to create more pods for a container, and it's needed for communicating to the cluster both locally or remotely. So we'll still need this in a proper production deployment as well. But we'll see it here in this local deployment that we'll do. So you can just go ahead and install that. And if you're on a Mac and you have an M1, M2 chip, it's quite simple because you don't need to install. You can just go through the instructions here. And I usually use Windows, but I actually just switched to a Mac because everything with Docker just seems to run smoothly with a Mac for some reason. So if you have a choice between the two, I'd recommend the Mac in that case. However, if you don't have an M1, M2 chip, or you are on a Windows machine, you might need to get what's known as a hypervisor. And that's in the instructions. You can just sort of follow that and get that and set that up. That'll just be an extra step. But with the M1, M2 chips, you can just go ahead and install it directly, basically, just following the steps. And then MiniKube here, this is a local tool. So it's a tool for testing Kubernetes locally, and it just uses the virtual machine on your machine to make a cluster on there. And we'll see, even though that it's going to be on our local machine, basically each of the individual services that we would expect to be deployed on different machines or EC2 instances or whatever, it will just give it a different port number, and they'll simulate what it would be like if it was deployed on different machines. And basically, if we test it on MiniKube, we only need to make a couple of tweaks, and then we'll be able to deploy things for real. So you can just go ahead and follow through that, get the Kubernetes kubectl, and also get the MiniKube. So we'll need both of those. And as I mentioned before, You also need Docker Desktop. So you'll need Docker Desktop, and what I'm going to do is I'm going to use Docker Desktop as the driver, because as I mentioned before, that integrates really nicely with the M1, M2 chips, so I don't need to install anything else. But if you don't have one of those types of machines, you'll need to get a hypervisor. You could get something like VirtualBox. I think that works on both. That'd probably be the one I would use. So basically, you just need to install that and then select that as your driver when you're putting start there. But I'm just going to use the Docker. And another thing to note is you should have a DockerHub account. This is super easy to do. All you got to do is go to DockerHub or hub.docker.com and just log in or sign up. And then you can go ahead and you can create your images. And one thing to note here is in Docker Desktop, you need to be signed in to your Docker account here. And that'll just make everything smoothly, because as you'll see here, we've got MiniKube running here. And we want to interact with that. And finally, before we get started, I just want to say that I have this repo here. So all the code is going to be in this repo, and you can just clone that. And you'll need to clone it if you want to follow along step by step, or you could just watch what I'm doing here. So with that said, let's jump over into the code. So I'm just going to open Visual Studio Code here. And as you can see here, what we have is we just have a basic NestJS application. This is just a hello world application essentially. And you can see the get hello method here. I've also created this other get method to the endpoint /crash, and that's just going to throw an error. And the reason I'm doing that is because we want to crash our server and make sure Kubernetes is redeploying another container and patching any errors that happen there. And then I also got this simple file post and get command. So just to have a look at that quickly, if we just send a JSON object with the text in Postman, we're just going to write a file called temp.txt. And at the moment, it's not going to append to it. It's just going to override it. And we're doing that to demonstrate persistent volumes, because when we turn off our containers and we exit out of it, we don't want to lose any data. And we'll see that this is actually going to be very similar to how you do it for a database. And so if you're interested in seeing like a proper deployment on AWS with NestJS and Postgres, let me know and I'll make a video if there's enough demand for something like that. But pretty much all the steps that we're going to do here today, they're 95% going to be able to reuse for a proper deployment. Obviously there's going to be some cloud specific stuff and some tweaks, but this is a really good first video to understand how Kubernetes works and how to develop locally in your local environment, and specifically for a NestJS project. But as you can see here, we just create this temp file, we post that, and we can go ahead and we can just get that as well. So nothing too fancy here. So what you want to do is, the first thing you want to do is just open the command line here. I'm just going to run a clear here. So what we're going to do is we're just going to check that we've installed things properly. So we're just going to run a kubectl version -- client. And if you get something there, that means you have the kubectl on your installed. So that's good. And the other thing you want to check here is the MiniKube. So you can just go ahead and you can just start it. And I've already done this, but you can just run MiniKube start -- driver. And let's say you're using Docker, you can just go ahead and use Docker. Or if you're using VirtualBox, you just type in VirtualBox. So perhaps you have a hypervisor rather than using the Docker on the latest M1, M2 chips. So I've already got that running, and you can see that running, and we saw it running before in Docker Desktop here. So with that said, what we can do is we can go ahead and we can create a repo on DockerHub. So let's go to DockerHub and create a repository. And let's just call this NestJS K8s. I'm going to call it PV2 because I've already got a PV1. Oh, and that should be NestJS. So NestJS, Kubernetes, and the 8 in Kubernetes, that just represents the number of letters between the K and the S. In case you're interested why there's K8s here. I've already done one, and I got PV here. That's going to be persistent volumes. And 2 is just because I've already got one repo called that. So this is just going to be a NestJS image, which works with Kubernetes and persistent volumes. So just go ahead and create that. So now we can see that we've got this here. And if you've never used DockerHub before, it's basically like GitHub, but for your Docker images. So what we can do is in at the root here, we can actually just go ahead and we can create a Docker file. So let's go ahead and do that. We'll create a Docker file here. And we'll also create a Docker ignore file. So Docker ignore. So in the Docker ignore file, basically what I want to do is I want to ignore the node modules, and in case you build it locally, and I want to ignore the Docker file, and I'm also going to do this where I'm going to ignore all of these YAML files, which we haven't created just yet, but essentially Kubernetes is all about just configuration files with these YAML files, and that's just like the set of instructions, and we want to specifically not include the Docker file and the configuration files into our image because they'll interfere, or it can potentially interfere with the how DockerHub does the build and how you retrieve the image and stuff like that. Probably it's all good, but just to lean on the safe side. So we just create this Docker ignore file here, and we'll also create a Docker file here. So if I look at my node version here, we can see that I'm on 18.13.0. So I just wanted to make sure that I got the same version as I've created this. So we can get the image from DockerHub, the node image, and I just want to get specifically version 18.13.0 just to avoid any versioning errors. So now what I'll do is I will type in the working directory. This is where this will be the main directory that will be on the actual container itself. So I'll just call that app, and call it whatever you want. And then what I want to do is I want to copy my package.json file over, and we might want the lock as well. So let's just do package star.json, and then I'll move it over into our working directory here. So what I can do is I can just run a npm run npm install. So that will just install all of our node modules on the actual container. And then we can copy all of our stuff over. So we can just copy everything from this root directory. And it's important to note that we're in the root of this directory. So we can copy everything over here. And then what we want to do is we actually want to build the project. So we can run the run npm run build, and that will use, if we just look in the package.json here, if we look at the start, if you look at the build command here, they'll just run the nest build command. So we got that. Our port, if we just look at the main TS file, we see that we're listening on port 3000. So this is just the standard hello world boilerplate basically. So what we want to do is we want to, because we're creating a container, even though it's on our computer, it's running on a virtual machine on our computer. So to be able to interact with that port that container exposes, we actually need to expose that port 3000 so we're able to access it from our machine. So our non-virtualized machine. So finally, what we can do after you've built a NestJS project, basically is going to create a dist folder. You don't have to do this locally, but it has this main.js file here. So we'll need node installed, and I've got the specific 18.13.0 version, so we can use the node command here. And then because we're in the working directory of the root, we can just go dist/main here, and by default we'll just look at the JavaScript file there. So you can just go ahead and you can just save that. So now that we've built the Docker file, we can actually push that to DockerHub. So basically what I want to do here is I just want to do a docker build -t to give it a tag. And this is where we give it the tag of our repo here. So we just created that before. And if I do docker build -t, John Pepping, which is my Docker account, username / the repo that I've created, and I want to do that for the folder I'm in. So I can just do this dot here. And that's just going to build our Docker image, which will run through the steps that we've outlined. And then what we want to do is we want to make it available to DockerHub. So we can just go ahead and we can just run a docker push command, and then we can just put in that repo there. Notice we didn't have to include any of the Kubernetes files, and this will just take a little bit. Now if we go back to DockerHub and we refresh this page, it might just take a moment, but we can see that we have got this latest tag here. So we actually have pushed our image to DockerHub. So what we can do now is we can go ahead and create our Kubernetes configuration files. And these are just YAML files that allow you to provision resources. So what we can do in the root here, and you could put it in a Kubernetes folder. Often you'll see folders called K8s or Kubernetes. Since we've got a pretty basic example here, I'm just going to do the standard, putting it in the root. So the first file we want to create is going to be called deployment.yaml. And it doesn't have to be called deployment.yaml, but it could be anything you want, or you could even make it more descriptive, like your microservice name, say to do -deployment. And a deployment, basically what we're doing in this file is we're just setting up, we're telling Kubernetes, or we have this configured file. So basically Kubernetes will just read this file. So we create this deployment.yaml file, and this file is just a way to tell Kubernetes how we're going to do things. And we're specifically doing a deployment here. And we'll see other things, for example, things relating to storage, and that'll be a different thing. And we'll have a way to communicate with the outside world. So there'll be a service, but we're specifically talking about the container deployment right now. So the pod deployment, I should say, which contains the container, and it also can have its own volume, although we want to have a persistent volume, and we'll set that up too. So we can just start, this is just a basic config thing where we just specify the version here. And actually I've got the DockerHub, I've got the extension for Kubernetes. And if you have that, you can just type in kind here, and you can also just type in deployment, and then you'll get like this boilerplate here. I'm just going to close the terminal for the time being, and I'll just make it a little bit bigger. So basically, by default, we got this apps/v1. That's just, that's a default. You can just find that on the Kubernetes Kubernetes website. You just leave that as is, basically. We've got this kind called deployment. We've got this metadata, so we just need to name our app something. So I'm just going to call this NestJS API PV2. It doesn't have to actually be called the same thing as what I've named it in DockerHub. Oh, I didn't even name it the same thing anyway. So basically, I'll just leave it as that, just to demonstrate that you don't need it to be the same. So what we can do now is we can, firstly, we can see we got this spec here. And spec, it should have replicas in it. So replicas is how many instances you want, essentially. So we just want to have one, but if you wanted to have more than one, you could specify there. And it's really easy if you start off with one and then you just change it to 2 and reapply the changes, then you'll see your project scale as needed, sort of thing. And that's one of the nice things about Kubernetes. It's just a super simple way to manage everything from this YAML file. So we have this selector here where we match the labels, and I'm just going to have the label, and this doesn't have to be called app, by the way. We could call this API. We just got to make sure that we have it called API everywhere. And the value, of course, you can change as well. So let's just call this NestJS API. So we're just specifying that this deployment is going to have this particular specification where we have one replica, so the number of desired pods, and we have the match label here. And because you can have multiple things happen here, and then we need to reference it, but right now we just got this NestJS API, and that's why, since we can have multiple things here, we just need to specify exactly what that is. So we have this template metadata labels, and that will be matching with that there. So this is the spec of the deployment. And then if you look at this spec, this nested spec, this is the spec of the pod. So remember that the pod, the deployment can have more than one pods, but this is what's happening within the pod itself, sort of thing. And for this, what we can do is we can have the containers, we can give it a name. I'll call it API. So you can have the image here. The image is going to be this here. So this is going to go to DockerHub, and if it's on DockerHub, DockerHub is the standard one, so you could just put in that. But if you're using something else, I think you need to put in the full URL. But we're using DockerHub, and basically that will just go to DockerHub and get our image. So we got all of our software that we need, which is basically Node, and then it has the installation steps and all that sort of stuff that we've seen in the Docker file. You'll get all of that stuff for us for the particular container. So when we create containers, all that will be taken care for us. So we don't have to do that over and over again. So basically, something you can add here is you can add colon whatever version it is. So we only have one version, but you could imagine that you'd make changes to your image. Maybe you change Dockerfile, or you change something in your application and you want to rebuild that image. Typically we just want to get the latest one, so you can just specify that. And an alternative to that is you can have this image pull policy, and we can set that to always. And if we just hover over this, and the good thing about this Kubernetes extension is if you ever forget or you're not sure what anything is, you can just hover over things and it tells you what it is. So you can just read like, oh, the image policy, pool policy is one of always, never, etc. And always, it means that the kubelet always attempts to pull the latest image, and container will fail if the pull fails. So you can specify pretty much anything in this configuration file as you need it. So you don't have to memorize anything at all. All you got to do is just have a sort of general understanding, and then just sort of tweak your configurations to your project requirements as needed. So basically what we want to do here is we say, okay, well, we're going to need some ports, and actually that's specified here. So I'll just put it here as well. And the ordering doesn't really matter of these things, but the indentation and sort of syntax with the colon does matter. So the container port is just going to be 3000. And if we look at these resources, these are just some default resources. Basically, all we're doing is saving some text to a file, not even much, just like a line. So we really don't need much at all. So you need to just sort of play with these numbers for your requirements. And you don't even have to have this here, but it's a good idea to have these limits so you don't exceed your resources and blow the budget. But here we see we've got this CPU, and we've got 500 M, and we've got memory here, 128 megabytes. So they're the limits we have there. Let's just keep those default limits. We don't really need to change it, although you could, for example, have a request limit. So you could have the CPU as 0.1, for example, and the memory as 128 megabytes. And I actually use a different value on that I've already pushed to GitHub, so I might just change that to, instead of 500 M, I'll change it to 0.5, and I'll make this 256. Not that it needs to be, but just to keep things consistent with what it is I've done previously. So pretty basic stuff here. We've got the ports here. Now we also want to have something known as a volume mount, so we'll come back to that in just a sec. But one thing to note is, like, how does Kubernetes know how to tell if your container's up? Like, how does it know how to restart a container or shut down a container, redeploy a container? And basically that's just built in, and basically it just checks like your slash endpoint by default at a periodic time, say 10 seconds. But you can actually overwrite that if you wish. So we have these ports here. Let's just move these ports up a bit. So we've got the name, we've got the image, we've got the image pool policy. Let's just put these ports here. We can have something else called a liveness probe. And a liveness probe, what that does is it just is like a health check. And we can have a HTTP, and we can do that on the path /, which I think it is by default anyway. And then we can specify the port to 3000. So in addition to HTTP GET for our liveness probe, we can also have a period in seconds, and we'll say every 10 seconds we want to make a HTTP GET request to / on port 3000. And perhaps we want to do that initially straight away. So you can also have this initial delay seconds, and I'll just set that to 2 here. So that's just a health check. So we can tell Kubernetes how, like, under what circumstance should we redeploy. So if you go to the endpoint / and it's failing, well, then it'll destroy that container, recreate another container, and it'll do that a few times. And it will incrementally double, I think. So it might happen in a second, then 2 seconds, then 4 seconds, then 8 seconds, and so on. And that's just a way to have safety over the number of things you provision. And you can have safety measures on top of that as well, like with these limits with resources and stuff like that. Plus cloud-specific stuff and monitoring. So we won't get into those details much more here, but just to sort of finish up on this deployment YAML file. Well, one thing we want to add to this is we want to add volumes. But before I do that, I might go to something even more essential, because you don't necessarily have to have persistence volume. So we've seen how we can create our deployment. Let's go ahead and we'll just create a file called service.yaml. And again, this could be called whatever you want. And this will just be a service. So let's just grab this. And API version v1, kind service, metadata. I'm going to call this API service. And this whole service, all it is just a way to communicate outside of the container. So we mentioned that before. So we got this spec, we got this selector, and this actually needs to be changed to API because we changed our key to API. And then we also changed the value to NestJS API. So let's just go ahead and use that. And that's how we can select to know it's going to be this deployment. Because you can imagine Kubernetes, you're going to have big deployments with lots of services. And right now we've only got one, but you can imagine once you have more, you need a way to select which you're connecting to and have a way to organize that. So basically, we can say, let's just say for the ports here, we want to use the protocol TCP. And we want to do that on port 80. So 80 is the port for HTTP. So we want to be able to make HTTP requests from our computer and to the target port of 3000. So this node server on the container is running on port 3000. But if we were to deploy to, say, AWS on a HTTP, so we want 80. And if you're not, I want HTTPS, you want 443. But we'll see with MiniKube that that port number actually gets changed anyway because we need a different way to connect to simulate we're on different servers. So, oh, and the final thing to note here, and the most important thing to note of this whole file basically, is this type here. So we have this type load balancer, and load balancer essentially means that if maybe we'll get some information if we hover over it. So basically it defaults to cluster IP, and that means you have internal communication. So if you have another pod, for example, like let's say you have microservice, you have an API gateway, you want that to be exposed to everyone, but then it goes to another microservice. You need a way to communicate from the first microservice to the second microservice. And in that case, you'd probably use something like cluster IP. Whereas load balancer is good for endpoints that you want to be available to the public, but it also, in addition to that, has a load balancer over your containers. So essentially you'll distribute load. If you have more than one instance running, it would do that for you. So that's a really important thing to note there. So what we can do now is let's go back to the deployment YAML file. And what we'll do is what we want to do is basically, like when we're on our local environment and we have the API call and it creates the temporary file or gets the text from the temporary file, we don't lose that file. But you can imagine if you have a container and then you shut down the container, well, that's lost. So we want a way to be able to keep that, and you do that with persistent storage. And if you don't set up, you'll just by default have it lost, but we'll set this up. So in line with resources here, we can put a volume mounts option here, and we can give it a name. So I'm just going to call it text volume, and then we need a mount path, and I'm just going to put this in a text folder, and we're going to call it temp.txt as the file is called, and then you can have a subpath if you wish, and just to help it know to go to the temp.txt file here. And with that, if we, I got to find exactly where this is now. If we go in line with containers, we can get the volumes. So just to note and reiterate, we have a pod which has a container on it. It can have more than one container, but typically you would just have one container on it, denoting your microservice. The container can also, or a pod can also have a volume, but typically that volume would be like with the container, so it would be lost. But what we're doing is we're specifically sort of overriding that, and we're creating persistent volume. So even when that container gets shut down, we can still access the information, and it'll just be stored somewhere else on the system essentially. So what we can do here is we can just give it the name, and we just specify the name above. So we'll just keep that same name there, text volume. And this is going to be a persistent volume claim. So we'll come to this in just a second here. And we've got to give it a claim name. So I'm just going to call it PVC. And I'm going to save that. And yeah, I was just making sure that the linting was working correctly. So essentially, firstly, we'll come back to this, but essentially all we need to know is we have this claim name, and essentially we're going to connect that to another file. So firstly, let's just go ahead and create a file called pv.yaml. This is going to be a persistent volume here. So let's just go kind persistent volume. And a persistent volume, we have this metadata, so we'll give it the name. Let's just give it the name PV. And we'll have a spec here. We'll give it, so for capacity, I'll just make sure, I'll just put something random here. So 1 GB, although you don't want it to be more than what you've requested. Volume mode, we'll have a file system because we just have a file here. Access modes, read, write once. We don't need this persistent volume reclaim policy. The storage class name, we can just make that standard. To use the standard options there. Mount options, we don't need any of those. NFS, we don't need any of that. So basically, all we've got here is we've got capacity, volume mode, access modes, storage class name, and then we want to have host path here as well. And the path that we want here, it needs to be the same as what we have in our deployment. So we have this text here, and we want this to be of the type directory or create. So if the folder doesn't exist, you'll create it. Otherwise, you just use the directory. So that's our persistent volume. And we'll note that that isn't necessarily a persistent volume claim, because that persistent volume, this is going to work regardless of the pod. But then to be able to use that in a particular pod, we need to have a persistent volume claim. So we'll have this pvc file .yaml, and in that file we can make use of it. So we can just say, well, we have the kind here, and the kind is going to be a persistent volume claim. So we can just call this pvc, and that pvc is going to be referenced by the volume mount for the deployment of the pod. So that's how that connects, and then that's how we can keep things. So we have the spec, and we need to have the volume names because it needs to reference that PV file that we just created. And to do that, we can just say PV, because that's what we called it here. And then the resources, the requests here, it can't be, more than the total that we've given it. So the total we've given it for the volume is 1 gigabyte. So let's just say, well, 1 gigabyte here. The volume mode, we've got file system here, although I don't think we actually strictly need that because we've got it outlined here. So we've got the volume name, we've got the resources, we've got the request, the storage, 1 gigabyte, access modes, read, write once. And then also we can have the storage class name, and then that needs to be the same as the other one. So we just go ahead and we put standard here. So before we apply all of those configuration files, what we can do is we can just run a kubectl, and we can say get pods, for example. And this is just to make sure that we don't have anything running that we've been working on previously. So since we've just started, we shouldn't have anything on here. And we can do the same thing for deployments. So we can get the deployments, see if anything's there. We can get the services. So none of that's there. So, oh, well, for the services, you get the default Kubernetes one, but that should just be there anyway. So now we can see that nothing is already existing there. What we can do is we can run the kubectl, apply, and then the -f for the files that we want to apply. So I'm just going to apply all the things we just created. So we've got the pv.yaml, and then the pvc.yaml. And I'm doing these first because they don't have dependencies. So pvc depends on pv, for example. And then the service depends on deployment. So we'll have a service.yaml here. And, the deployment depends on service. So we can also just say, okay, let's take the deployment YAML file there. So I just run a kubectl apply -f equals, and then all of the YAML files in order. So from least dependent to most dependent. And I just ran that, and that just configured all of the YAML files that we just created. So with that, we can go ahead and we can run a MiniKube command, and then we can run the service for the actual API service that we've created here. So let's just go ahead and run that. And we can see that it opens up a Hello World application for us. So I'm going to go into Postman, and I'm going to check that everything works here. So firstly, I'm going to run this endpoint here, so that works. And then I'm going to try crash the application here. And we get a 500 internal server error, and that should crash our pod. But if we rerun this here, we see we get the hello world again. So we can see that it actually reran our broken pod, or our broken container. So let me post, say, hello world with 2 exclamation marks, and I'll save, and I'll post that. And then I'll try and get it. And then you can see that I get it with 2 exclamation marks there. So that makes sure that that works. But the interesting part of this will be, let's just say Control C, so we stop that from running. And then when we run it again, it'll be on a different port, simulating a different machine. But what we can do is we can actually go ahead and we can undo all the things that were created by running these. And you can do that by running a kubectl delete, and then you can delete all of the files. They'll delete everything that was created with that. It'll delete all the resources that those YAML files provisioned for us. It doesn't delete the files themselves, it deletes the things that they created. We could rerun this, for example. So we could just run the kubectl, apply all of the files again, and then it recreates everything for us. And then finally, if I run a MiniKube and I start the service for the API service again, with an E at the end there, we can see that it takes us to this new port, which simulates that it's on a new computer now. So 55274. So if I try to get this on the new port, so it was 55223, now it's 55274. I try and get this, we can see that it actually does get this again. And of course, we just saw a minor exclamation mark because I was playing around things as I paused the video. But you can see that the pod is persistent here. So we've turned it off, we turned it back on, we've got a whole new server, which is, it basically simulates that we got a whole new EC2 instance, container rerun, and we didn't lose the data, because typically you wouldn't get anything back at all. And then now we're able to get that. So let me know if you want to see another video after this, which would be, say, Postgres and NestJS on AWS, just so we can sort of have that finale there. If there's enough demand for that, I'll make a video on that. Let me know. Okay, thanks so much for watching, and I'll see you in the next video. Cheers.